All right, now here's the formula for compound interest over time. A equals P times 1 plus R over N to the NT. Now both N and T are next to each other and they're in the exponent of this formula. So you'll notice this formula is a little more complicated than simple interest, and that's because the process for finding compound interest is more complicated because you have to recalculate the interest every time you earn it. The nice thing, though, is that these variables we're using are almost all the same as with simple interest. A is still the future value of the investment. P is still the principal or the present value of the investment, or remember, that's just another way of saying starting amount. R is the interest rate as a decimal, and specifically it's the annual interest rate. In fact, sometimes what people will do to abbreviate R is they'll say APR, standing for annual percentage rate. So if you ever hear somebody say APR, that's standing for the interest rate involved in that scenario. T is the time in years. Again, it must be in years. And there's one extra variable in the compound interest formula, and that has to do with compoundings. N is the compoundings per year, and what I mean by that is how many times we earn interest per year. So basically, number of times interest is earned per year, and we call that compoundings. Now, in the example we did in the table earlier, which I'm going to go through with the formula, where we invested $5,000 in an account earning compound interest annually at 8%. So this interest was compounded annually. Notice it said compounded annually. That means we're earning interest once per year. So when we think about N was equal to 1 in this case. We earned interest one time a year. But it is possible to earn interest 4 times a year. That would be called quarterly interest, or 12 times a year every month. That would be where you compound monthly. But this N is an important aspect of compound interest because it's telling you how often you earn the interest. Now let's take a look at what we did for the example in the table, which was investing $5,000 for 5 years at this compounded annually. Using the formula, I would get my future value by taking the initial amount, which is $5,000, what we call our present value, and multiplying it by 1 plus R, 0.08, divided by N is the compoundings, and that's just 1 in this example. We're going to earn interest once per year, raised to the power that is N times T, so 1 times 5. 1 times 5. Oops. And one thing about this calculation, it is a little more intense to do. One thing I recommend is calculate the exponent before you put everything else into the calculator. And this is a pretty easy calculation with our to do. We could do that in our head. 1 times 5 is just 5. But it becomes really important when we're doing more complicated examples with compound interest where the N is not 1. So basically, what I recommend is do the exponent first, then throw the rest of this into your calculator. Use the parentheses buttons of your scientific calculator. So you would have 5,000 times parentheses 1 plus 0.08. Now you could divide by 1, but you don't have to. Anything divided by 1 is just that thing. Close the parentheses and then raise it to the 5th power. And the button for raising something to the 5th power in a scientific calculator often looks like a little up arrow. It's called a caret, or you might see it as something that looks like y to the x. That's the button that says do an exponent. So 5,000 times parentheses 1 plus 0.08 divided by 1, close parentheses raised to the 5th power would give us, and we do have to round here, $7,346.64, which is exactly what we got in the table. But this formula is much faster than doing the table out. calculation after calculation after calculation. We had to make 5 separate calculations to get this one value and come up in the table. And I should say 5 separate calculations of interest. That doesn't include adding the interest on to the previous balance. So this is much quicker. And you can imagine if we were to go out 20 years, how much nicer this formula is. And the only thing that changes if we go out 20 years is the time. Everything else would stay the same. So we have 5,000 times 1 plus 0.08 divided by 1 to the 1 times 20. And as we know, 1 times 20 is just 20. So I can just throw that into the calculator as 20 in the exponent. And I would get, when I calculate this, again, use your parentheses, $23,304.79. So that's how much we have after 20 years. Now, I have one more question here, and that is, how much interest do we earn after those 20 years? Well, remember, the interest is always going to be equal to what we end up with, A, minus what we started. So if I take what I ended up with, which is $23,304.79, and subtract what we started with, which was 5,000, so 23,304.79 minus 5,000, we'll get the interest as being $18,304.79. So the interest that we earn on the account, oops, I was trying to highlight that. The interest that we earn from this account is going to be equal to $18,304.79 after 20 years. So there is a difference between how much we have left in the account after 20 years, which includes what we started with, and the interest that we've earned.